All right, number 11, we want to find the zeros of the polynomial function and state each multiplicity. All right, so what we see is a polynomial equation. Looks similar to a quadratic, but it's not quite. But you can solve it by factoring, or at least we will try. If you notice that you have those three terms, similar to quadratic, so quadratic looks like this: ax squared plus bx plus c. Okay, if the relationship between the two variables is double, so the middle variable is double, is half, or the leading variable is double what the middle is, then you can still use that factoring technique. So this is 4, this is 2, so this one is double that one, and it will work every time if you have three terms, given that you have a double out front, half in the middle, and then no variable at the end. So we're going to try to factor this just like we would normally. So I'll multiply the first and last number, 1 times 2. And then the factors of 2 are 1 and 2. And then we would have to add, because of the back sign, to get 3. And these two numbers do in fact add to give us 3. So in the factoring process, we're going to do our two sets of parentheses. And the difference is, instead of just putting a single x in each of them, we're going to separate the x to the 4 evenly. So we'll have x squared here and an x squared here. And then we will add the two numbers we found, 1 and 2, at the back. Going left to right, the first sign tells us the sign of our larger number, which would be 2. So we get a minus here. And then the second sign tells us they're the same. Positive means they're going to be the same. So they're both going to be negative. All right, and then at this point, we have factored our problem. And then we're going to set each of these equal to 0. So x squared minus 1 equals 0. And then we get x squared minus 2 equals 0. So if we add 1 to both sides, and then we take the square root. Whenever you take the square root of a number, you got to remember positive or negative. So we get x equals positive or negative 1, because the square root of 1 is 1. So the square root goes away on this side. So we get two solutions, positive 1 and negative 1. On this side, we get x squared equals 2 when we add 2. And then when we square root both sides here, we get x equals positive or negative square root of 2. So 2 is not a perfect square, so we leave it under the square root, and we get two answers here, positive 2 or negative square root of 2. All right, so now we want part 2. Each 0 has a multiplicity, so how many times does each 0 occur? So from the factored form, we didn't have any squares or cubes. Each of these numbers only occur one time.